So now we're going to go into solving equations. So what we're doing is we're taking an equation which is just a statement that shows, I missed the S there, shows two equal math statements. So something like 4x plus 1 equals 7. That is an equation, and so it's going to be important that it has an equal sign in it. So if it has an equal sign in it, and we're usually looking at an equation. So just look for that equal sign. You know, it's something that you might be able to solve. So oftentimes we're asked to solve these equations, which means we want to find the value of the variable that makes the equation true. So there's a couple steps when we're doing this, a couple key things to keep in mind. One of the first things is that we're going to use opposite operations when solving equations. So the opposite operations for these various terms, the opposite of adding something is subtracting it. The opposite of subtracting then is adding. The opposite of multiplying is dividing. The opposite of dividing is multiplying. The opposite of squaring something is taking the square root of that. And the opposite of a square root is to square it. So we would square that. So these two just become the opposite. It would become A there, and again this would become A in those situations. But remember, it's just the opposite operation. So we'd square a square root, we take the root of a square. So now there's three key things to remember when we're solving these. The first most important thing is we're getting the variable by itself. So that letter, we want to get it by itself. In grade 10 and on, you might use more than one letter, but in our case, we're going to be focusing mainly on one letter. So we want to get that variable, that letter by itself. We want to use those opposite operations when we're doing that. And using what my teachers used to call the golden rule of algebra, do on one side that which you do on the other. So whatever you do to one side, you have to do the same thing to the other. And we've already done some of this when we've been solving equations with Pythagorean theorem. And again, we're just formalizing this concept. So we have some equations that take one step, some that take 2 steps to get through, and then some that take a whole bunch of steps depending on how big they are. So we'll go through each of those and see how they work. So given some one-step equations, we have 4 examples here. I have the first one, x plus 7 equals 5. Now you might be able to figure out some of these in your head without doing anything, but it's a good idea to practice the process so that when you get questions that you can't just do quickly in your head, you know what process to use to solve it. So something plus 7 is 5. So we want to get rid of this 7 to get the x by itself. So we have to use the opposite operation, and we're going to subtract 7. So we have x plus 7 minus 7. That will get rid of the 7, but we did subtract 7 on this side, which means we have to do the same thing on the other side. So we have 5 minus 7 on the other side. So here, 7 plus 7 minus 7, those will become 0 or just go away for our purposes. And then 5 minus 7 is negative 2. So we get x equals negative 2. Now you can always go back and check these. If you take that 2 and put it in for the x, so we have negative 2 plus 7. Negative 2 plus 7 is 5, so that would make that true. That way we can verify that we got the right answer. In the next case, I have x minus 5 equals 8. So the opposite of subtracting 5 is to add 5. So I have x minus 5 plus 5 equals 8. Minus 5 plus 5 becomes a 0. And then on the other side, I needed to add that 5 as well. I added a 5 here. I have to add a 5 here to keep the equation equal. 8 plus 5 is going to give me 13. And again, I can check my answer. 13 can go in for the x here. 13 minus 5 is 8, so that is correct. In the next one, I have some multiplication. I have 3 times y equals 18. And so to get rid of times, we need to divide. So we actually need to take both sides and divide them by 3. And I like writing my division like this when I'm doing solving equations. I find it's easier to work with along the way. So here we have 3 and 3. Those will divide out, become a 1. So we just have a 1y or y on this side. And then over here we have 18 divided by 3, which is going to give us a 6. And again, we can check and see if this is right. Take that 6, put it in for the y. 3 times 6 is 18, so we did that right. In this last one here, I have x squared equals 49. So the opposite of squaring is to take the square root. So I have to take the square root of both sides. So the square root of x squared and the square root of 49. The square root of x squared is just x, and the square root of 49 is 7. And again, we can check our answer. Is 7 squared 49? Yes, it is. So we did it right. So one-step equations, you're just moving that one piece. You're doing that one opposite operation. So here, if we're adding, we're subtracting 7. Here we were subtracting 5, so we added 5. Here we multiplied by 3, so we divided by 3. Here we were squaring, so we took the square root. We just do that opposite operation. And we do that to whatever we do to one side, though, we make sure we do it to the other side. That leaves us with our variable all by itself. Now, let's step up the difficulty, and we'll look at some two-step equations. So here we have some two-step equations. We have 4x minus 2 equals 10 in our first case. So the question might be, well, what do I do first? Do I divide out the times 4, or do I move the minus, or do I add a 2? Well, we do opposite operations. We do things in opposite order. So in this case here, if we were calculating this, it would be 4 times x minus 2. So we have to reverse that to undo that idea. And so what we do in this case is we need to add 2 to both sides. So 4x minus 2 plus 2 equals 10 plus 2. So we add 2 to both sides. We're left with 4x on this side. We're left with 12 on this side. Now we're down to a one-step equation, and we can divide both sides by 4 to get rid of that times 4, because multiplying, the opposite is dividing. So we're just left with x here. And on this side, we get a 3. In the next case, we have 3 minus 2x equals 1. So for our purposes, when you have a number out front like this, we can treat that like an addition. So we're adding a 3 here. So plus 3, and then the minus 2x equals 1. So the idea here would be that we got to get rid of this 3. And so to get rid of that 3, we have 3 minus 2x. And since that's a positive 3, we're going to subtract 3. And we'll subtract 3 from both sides. So we have 3 and minus 3 here. So those become 0. So we have negative 2x equals negative 2. And now we can divide both sides by negative 2. Why am I not dividing by positive 2? It would be a good question to ask here. Shouldn't I switch? I get these negatives when I have a positive here. Why don't I use a positive on the division? Because we don't have a negative here. We have a subtraction. Remember, this was the opposite of adding 3, is subtracting 3. So the opposite of multiplying by negative 2 is to divide by negative 2. The sign doesn't change in this case. We change the operation. And so here we're left with x. And on the other side, 2 negatives divided make a positive. 2 divided by 2 is 1. X is 1. And again, just like the one-step equations, we can check our answers. I can take that 1. I can put it in here. 3 minus 2 times 1 would be 1. So I know I got the right answer there. So let's test this, or check this last one. So in this case here, unlike the last one where I had a positive 3 at the front here, I got a negative 4. So what I can treat that is a subtract 4. So the opposite of subtract 4 would be to add 4. So I'm going to add 4 to both sides. That'll get rid of the minus 4. So add 4 to both sides, and the 4's will become 0 here. I'm left with 6x here. And then negative 16 plus 4 will give me negative 12. And now I got times 6, so I can divide both sides by 6. I'll get left with an x on this side, and then negative 12 divided by 6 is going to be a negative 2. So when you come up with multiple steps like this, with the 2 steps in this case, you look at the order that you would do things normally if we knew the value of x. So order of operations would say multiply first, then subtract. So we have to do everything backwards. So that's why we got rid of the 2 first, and then we got rid of the 4 next. So we got rid of things in the opposite order of bed mass. So now if we move down to these multi-step equations, we have things, some of them have variables on both sides. You can see here we got some brackets in there. This one has even more numbers. So we'll go through those. Using those same processes, we want to get the variable, the letter by itself. We want to use opposite operations, and whatever you do to one side, you do to the other. So the first one here, we want to get the variable by itself, which means we got to get the x's onto one side. So if we want to get the x on one side, let's get them all. I like to get them on the left side usually. It doesn't matter. You can get it to the right side. You'll get the same answer. But I usually like going to the left side. So we're going to get rid of this plus 7 here by subtracting, or 7x by subtracting 7x. So we have subtract 7x on both sides. So by subtracting 7x from this side, we get the x's just on the other side. So here we have, on this side, 8 minus 7x, like terms here. So we have 8 minus 7x, which is just going to leave me with an x. And then there's still a minus 2. So I got 1x or x. And on this side, positive 7x minus 7x is going to be 0x. And so we can just ignore it. And we have minus 9. Now we're back to a one-step equation. In this case, we will add 2 to both sides. And that will get us our final result of minus 7. So in the case where there's a letter on both sides, what you need to do is move get the letter, rid of the letter on one side so it's just on the other. So that's what we did here, and then we were able to do it like our standard equations that we've been working with. Now in this next one, we got some brackets. And there's 2 approaches to this. You could divide with the bracket part first. The best bet though here is to expand those brackets. So we multiply out those brackets and then we go about solving that. So that first step is to actually multiply the bracket. That will make things a lot easier for us. So let's get rid of the brackets first on this one. So whenever you see brackets, just get rid of them by multiplying or expanding that bracket. So remember, when we expand these, we multiply each term inside the brackets by the term outside. So we have 6 times 1 is 6, and 6 times 3w. And again, we just multiply the number portions. 6 times 3 is 18. And then a w. So now I have something similar to my previous question, a variable on both sides. I want to get rid of this 18 here. And so to get get rid of the 18 w, I have to subtract 18w from both sides. And now I have negative 18 minus 6w minus 18w. That will give me negative 24w. 18 minus 24w on this side. And on the other side, I'll just be left with the 6, as 18w minus 18w is 0w, and it's gone. Now I have to get rid of that negative 18 on this side. So to do that, I will add 18. Negative 18 plus 18 is just going to leave me with the negative 24w there. 6 plus 18 going to give me 24. And now to get rid of the negative 24w here, or negative 24, which is a multiplying, I'm going to divide both sides by negative 24. Those will just leave me with w, and this will leave me with a 1. So in the case here where we have a bracket, we expand that bracket first, then we get rid of the letter from one side completely so that it's just on the other, and then we can go about solving our equation. Now on this last one here, again we have letters on both sides, but we got a bracket, so let's deal with that bracket. Just makes things easier for us. So we'll multiply everything in the bracket by the number or term outside the bracket. In this case, it's a 2. So 2 times 4 is 8, and then the x. 2 times 3 is negative 6. Then we have a minus 8 equals 4x plus 2. Now in this case, I have a minus 6 and a minus 8. I can simplify this and get those down to one term by subtracting. And so I have negative 6 minus 8, and that's going to give me negative 14 equals 4x plus 2. From there, I'm going to get rid of the 4x on this side by subtracting 4x from both sides. And when I do that, I'm left with 4x minus 14 here. And on the other side, I'm just left with 2. And then on this last part here, or a couple more steps, sorry, I got to get rid of this 14 on this side. So I got to add 14 to get rid of a minus 14. And so add 14 to the other side. I'm getting 4x equals 16. Now I'm running out of room here. So what I'm going to do is just use an arrow to mark that I'm starting this over here. So 4x equals 16. And then that last bit, I got to divide both sides by 4 to get rid of the times 4. I'm left with x equals 4 as my result there. So when you have equations that you're trying to solve, expand out brackets just makes things easier to do along the way and ensures that we don't end up with some fractions that we might not want. And then once you've done that part, what you can do is get rid of the letters on one side and then get rid of any numbers and work your way through step by step, again using that opposite operation concept. So now you might also be given word problems with these. When in the case where we're given a word problem, we've worked on making formulas like this before. So we just got to read through and see what's important here. In this case, it costs $78 for 4 movie tickets and $30 worth of popcorn. Write and solve an equation, it should be an equation, to determine the cost of each ticket. So the cost is $78, and what you get for $78 is 4 movie tickets and $30 worth of popcorn. So it's not $78 for the tickets and then the $30. It's $78 for that and that. Is how that is read. So $78 for that means it's 78 equals 4 movie tickets. We don't know the cost of the movie tickets. This is a dollar value, this is dollar value, but we don't know the cost of the movie tickets. So it's 4 times the price of the tickets, and we can use something like T maybe for the price of the tickets. So 4 times the cost of the tickets plus the $30 worth of popcorn. Now if we want to go about solving this, we just use our opposite operations and rearranging the and setting up the equation the same way we have been. So we want to get rid of the plus 30 here first. So we're going to subtract 30 from both sides. So we're just left with 4t on this side. And over here, 78 minus 30 is going to leave me with 48. And then to get rid of the 4 that's being multiplied here, we'll divide both sides by 4. We're left with a t here. 48 divided by 4 is going to be 12. So right there, we have the tickets. Cost $12. So that is some solving equations. One of the things to note, and I don't think I mentioned it, but if you noticed, I try and keep my equal signs lined up. Some people don't care about it, and they'll do fine, but this lining up of the equal signs does tend to help. And this is from people that are experienced with math and top-level mathematicians keep their equal signs lined up. Not only because it looks a little neater, but because it helps keep things organized in your head and allows you to see what's going on a little better, and it will ensure that you understand this a little more effectively as you progress. All right, so that's it for solving equations.